So we are going to, given the special right little, the little formulas that we've talked about yesterday on special rights, we're going to find the three trig functions of 315 degrees. And I have stressed this over and over again, and I will continue to do so throughout this lesson because we're going to see different things that they're asking. And if you're not exactly sure what they're asking, it's going to be extremely confusing. So when it says the three trig functions, I'm looking for sine, cosine, and tangent. If I'm looking for sine, cosine, and tangent, the only thing I'm looking for, guys, is the ratio. I'm looking for opposite over hypotenuse, adjacent over hypotenuse. I am not concerned about the angle measurement at this point in the game. I only want to know what is the ratio for sine, for cosine, and for tangent, and that's what I'm looking for, okay? So, going to set this up. If I am looking for the three trig functions of 315, first thing I ask is which quadrant, first, second, third, fourth, is 315 degrees in? It is in the fourth quadrant because it's between 360, I almost wrote 270 there, and 270, okay? It lies in between. I really don't care where it lies, but I'm just going to draw my angle measurement there. Okay? That is 360. It started out to be 270, so that's why it's a really fancy looking 3. Okay, so that's my 360 degrees. I know that I am looking for 315, which is actually this angle outside. Okay? This is the angle that I am looking for, the 315, but in order to find that, I'm going to be actually looking for the reference angle, the angle made up from the terminal side of 315 and the corresponding x-axis. And so I make myself a right triangle up to that x-axis, never, ever, 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 ever to the y, always to the x. And that reference angle is what I'm curious about. So I'm going to take 360 minus 315, and I get a 45-degree angle. Well, isn't that convenient? Because if that's a 45-degree angle, and I know my hypotenuse, well, wait a minute. How do I know my hypotenuse?
It's a unit circle.
Bingo. It's a unit circle, so my hypotenuse is always now and forever will be 1. And it will remain positive. My hypotenuse does not change as the positive or negatives go. It will remain always a positive 1. So I look at what we talked about last week, and on a 45-45, if the hypotenuse is given of a 45-45-90, how do I get to my side? Divide by square root of 2. So this is 1 divided by the square root of 2. The other side is exactly the same. Our positive and negatives are going to play a huge role in this. So from on the x-axis here going to the right, is that a positive or negative 1 over square root of 2? What about this going down? Grant, you have a question?
What's the end on the side?
30, 60, 90s? Medium, like the middle length.
And then the S is small, H is
Mm-hmm. All right, so there I have my lengths. For sine of theta, which is 315, it's opposite. So my central angle is always what's in the middle, is negative 1 over square root of 2. Cosine of theta is adjacent, 1 over square root of 2. Tangent of theta was opposite over adjacent. I don't know if I'm going to last, which equals negative 1. Finding our reference angle and then being able to use our special rights to come up with our side lengths. Okay? And those steps are given there, 1, 2, 3, 4, 5, right above. Again, to kind of step you through that. The second one, 210, what quadrant? Third quadrant. Again, it really doesn't matter where I draw my angle. Understanding from the initial side to the terminal side, that is what creates the original angle of 210. I'm looking for this reference angle, the central angle that's created from the terminal side to the x-axis. I know my hypotenuse is always and forever will be 1. To find this angle, my reference angle, drawing up to the x-axis is 180 degrees, right there to the left. So I'm going to take 210 minus the 180, and I see that my reference angle is 30 degrees. So what that tells me is I have a 30, 60, 90 degree triangle that's created right here. And then off to the left, you have your hints for 30, 60, 90. If my hypotenuse is given, to go from my hypotenuse to the short side, I divide by 2, so that becomes 1/2. And to go from the short side to the medium side, I multiply by the square root of 3, so this becomes root 3 over 2. Those side lengths right there, guys, just came from the rules of your special rights. Now let's watch our positive and negatives. To the left on the x-axis means it's negative. Going down on the y also means it's negative. So both those would be negative values.
Would it just be just negative root 3?
Well, it's negative 1/2 times root 3. Everything comes off of the short side. We never go from medium to hypotenuse, hypotenuse to medium. It's always in terms of the short side. So then I can find my sine theta, negative 1/2, cosine theta, negative square root of 3 over 2, tangent theta is sine over cosine, or opposite over adjacent. If I divide by a fraction, it's the same thing as multiplying by the reciprocal. The 2's cancel, so I'm left with 1 over root 3. Understanding that sine cosine tangent of 30 degrees is synonymous with sine cosine tangent of 210, but the only difference is our plus and minuses, our positive and negatives when it comes to sine and cosine on that. Okay, questions on that? All right. What we have now is a very bare blank unit circle. Well, it's not completely blank. But this talks about when and where, and this is hugely important because we're going to be looking at some word problems that's going to utilize when is sine positive, when is sine negative, cosine positive, cosine negative, etc. So understanding that this is my first quadrant, second, third, and fourth. Those are my quadrants. There's an acronym that stands for all students take classes. All students take classes, and we write that acronym in the order of the quadrants. And what the A stands for, all. That means that all the trig functions are positive in the first quadrant. The S stands for sine. Only sine is positive in the second quadrant. The T stands for tangent. Only tangent is positive in the third quadrant. And C stands for cosine, and only cosine is positive in the fourth quadrant. So all students take Okay? Very important. Then we also know that in our coordinates, this is x, this is y, this is cosine, and this is sine. Our x value always coordinates with our cosine, our y value always coordinates with our sine function. Okay, given that, now we're able to look at this problem down below. Because understanding which quadrant, what's positive and what's negative is hugely helpful as we move forward. So down below, it says we want to find sine theta and cosine theta, given that tangent theta is 4/3 and cosine theta is less than 0. Now let's just stop a second and look at sine theta and cosine theta. What am I looking for? You're either going to be looking for an angle measurement or you're going to be looking for a ratio. On this problem here, is it an angle or is it a ratio? Why do I know that it's a ratio? You're absolutely correct. Well, number one, it gives me a ratio, but that doesn't always necessarily mean that's what I'm looking for.
It's not asking for theta, it's asking for sine.
Absolutely. It's not asking for theta. It does not say find the angle, find theta. If you flip over to the other side or just look at what I have up here, the last problem that we're going to be working says find the value of the angle. Specifically says angle. It specifically says angle or theta. Over here it doesn't. It just says find sine of theta and cosine of theta. I'm looking for a ratio. That's all I'm looking for. I'm looking for opposite over adjacent and opposite over hypotenuse and adjacent over hypotenuse. Okay, here. All right, so let's see. We're going to kind of play detective. Given the clues that are given, what can I come up with? Well, I know that tangent theta is 4/3. Is tangent right here positive or negative? If tangent's positive, what two quadrants am I in?
Oh.
First or third? I don't know yet. Okay, first or third, I don't know yet. But cosine's negative. What two quadrants have cosine negative?
Go. And
Second and third, cosine is negative. So what satisfies both of them? Which quadrant? Because tangent's positive and cosine is negative, the quadrant that I have to be in is in the third quadrant. That's hugely important because then we're going to understand our positive and our negatives. Okay? So I'm going to draw myself a third quadrant, and I'm drawing myself an angle. This angle theta doesn't matter to me in the least. I'm not looking for that. Okay, draw my right triangle. But everything that I'm doing is in terms of theta. So I know that tangent is opposite over adjacent. So opposite is 4, adjacent is 3. I'm in the third quadrant. That's going down, so that needs to be a -4, and that's going to the left, so that needs to be a -3. And if I have -4 divided by -3, that does end up to be a positive 4/3. Everybody good? Okay, what's missing on this triangle if I want to find sine and cosine? My hypotenuse. Have you guys heard if the legs of a right triangle, one is 3, one is 4, what's automatically my hypotenuse? 5. It's called a 3, 4, 5 triangle. That also is hugely helpful for your standardized test. If you didn't know that, no big deal. 3 squared plus 4 squared gives me c squared. And this would be 25. You add those together. You add those together, that's 25. Take the square root, you get 5. So now I can easily come up with my sine and my cosine. And I'm finished.
so when can you know that the hypotenuse is going to be 1? So why would
If nothing else is given. If nothing else is given. So like if this ratio is already given, I have to compute that hypotenuse. But if I'm going back to look for the legs of the triangles, if neither one of the legs are given, then I can make that assumption that the hypotenuse is 1. Because that's exactly what these are. These are ratios. So well, I don't know what this angle measurement is here, but if I would divide everything through by 5, then I can get to, or if I could, then this would get this to be 1, and it would be the exact same thing. Okay? All right, flip to the back side, last page. And this unit circle is very similar to what we just saw. But what it's doing here is it's proving why cosine is x and sine is y. So let's just go ahead and help this little and create our x and our y here. This is my x-axis, this is my y-axis, getting out to the point on the unit circle where the point is 1. And I'm just going to find cosine of theta. Here's my theta. And cosine I know is adjacent over hypotenuse, which is x over 1, which leaves me with just x. Sine of theta is opposite over hypotenuse, y over 1, which is just y. Tangent theta is opposite over adjacent, which is y over x. Which is my y, substituting in, I know is sine, x is cosine. And putting it like this, if tangent is y over x, that means that's my change in y over my change in x. Therefore, we have found that my tangent is nothing more than slope. And those of you that are choosing to go on to calculus next year, this is going to be a huge piece of what you're going to be looking at. You're going to be looking at the tangent of certain points, finding actually the slope of a certain point, not necessarily the slope between 2 points, but the slope of a specific point. And this right here explains it, that cosine theta is my x, sine theta is my y, and tangent is the change in y over change in x, which is slope. So on our unit circle, which we're going to see tomorrow, you're going to have cosine theta, sine theta, which is my x and y. And that's, if you want to be able to understand how to read your unit circle, understanding that right there is critical. All right? Okay, we've got a few problems down here that we're going to work, and then we're going to call it a day. And again, understanding that this is all students take classes fits in with all that as well. Okay. All right, true or false? If theta is an angle of a triangle such that the cosine is less than 0, so cosine is negative, then theta is obtuse. What's obtuse mean? Greater than 90 degrees. And if cosine is negative, what quadrants is cosine negative?
2 and 3.
Okay, 2 and 3. So I look at my picture, and if I want to get to the second quadrant, have I passed 90 degrees? Is the second quadrant greater than 90 degrees? Mm-hmm. Is the third quadrant greater than 90 degrees? Mm-hmm. So is this question true or false? It is true. So in order for cosine to be negative, the angles that are created for that have to be greater than 90. So that's true. Okay. Now we have 2 more problems, and I want you to label them 1 and 2 because 1 is going to be worked over here to the side and 2 is going to be worked down below. And I don't want that to be confusing to you, okay? So here it says, and we looked at this when we were looking at the ratio, but now we're actually trying to find the angle. So we want to find the value of the angle in radian mode that satisfies this. Now we're going to do this 2 ways. First way, we're going to use a calculator. And then we're going to look at how do I find this without a calculator, because Friday's quiz, there's no calculator, okay? So you're going to have to be able to find this without using a calculator. honestly, if your unit circle is accurate without a calculator, is as easy, if not simpler, than using a calculator. You can trust me on that. Okay, so right now, cosine, is this positive or is this negative? Tangent is negative. What quadrant? So I'm in quadrant 4 where cosine's positive and tangent is negative. So here I go. Draw my 4th quadrant. And again, the angle measurement, that where you draw it really doesn't matter. As long as it's in the 4th quadrant and it's not squished up against one or the other of the axes, you're fine. Okay. So I draw my triangle. This is theta. And again, I want to find what theta is. I need to find what theta is. So I'm looking for a reference angle, but unfortunately, I don't have an angle in which to, I don't know what this is either. Okay? I don't know what that is. So this is where we can use our calculator. Well, I know that this is 1 and this is 2 because adjacent over hypotenuse. So what I'm doing, I know that cosine theta is 1/2. And if I want to find what is theta, I'm going to use the inverse function and find out what is theta. So on your calculator, you're going to take the inverse cosine of 1/2 and tell me what theta is. Okay, so now I know that that is 60 degrees. What does that make the outside big angle? The obtuse angle? 360 minus 60 is 300 degrees. Okay, that's what I'm looking for. That's 300 degrees. But I want it in radian mode. So I'm going to take 300 times pi over 180. I'm doing my conversion. And remember, I don't want decimals. So this one's pretty simple. Cross my zeros off. I get 30 over 18. Divide both those by 2. I get 15 pi over 9. What can divide both into those? So I get 3 pi. That would be wrong. That would be a 5 pi over 3. And that would be my final answer. But Meyer, we can't use a calculator on Friday. You're exactly right, children, students. But you do have your handy-dandy unit circle. So you're looking for the cosine, inverse cosine of 1/2, correct? What quadrant are we in? 4th quadrant. Cosine, is that my x value or my y value? Okay. Can you see me up here? So I'm in the 4th quadrant. I look, where's cosine 1/2? Hot diggity dog, there it is. And there's my 300 degrees, and there's my 5 pi over 3. That's what I'm saying, like without a calculator, it's actually easier to come up with that versus typing all that in and then converting it into radians.
We have to know how to.
You have to know how to get this. We'll deal with that tomorrow. Okay? Yeah, tomorrow will be, I'm not going to say mind-blowing, but it is kind of cool how simple it is to create the unit circle. Okay, Evan?
And so after we want to do this, like, we'll be able to use it on the quiz and stuff.
Say that one more time.
Like, we'll be able to use this on the quiz.
You will have to create your...
We'll make one, but-
Yes, yes, yes. Okay, so let's do this last one. Tangent is negative. Cosine is negative. Which quadrant? Second. Tangent negative, cosine negative, so I'm in the 2nd quadrant. The angle in which you draw doesn't matter, or the location, except for being specific that's in the 2nd. Where it lies in the 2nd isn't as important. Drawing my right angle. if tangent is negative and it's -1, then I know that I'm 1 over 1 because it's opposite over adjacent. So opposite's 1, adjacent is 1. And because it's negative, one of those has to be negative. And it would be the adjacent because that is on the x-axis going left. Those are negative values. Here's my theta. So I'm looking at inverse tangent of -1 is going to give me theta. If you type that in your calculator, you'll find that to be 45 degrees. To find this angle, that's the angle that we're actually looking for. I can take 180 minus 45, and that's the angle I need to convert to radians. 135 times pi over 180. Divide everything through by 5, and then dividing it again, you eventually end up with 3 pi over 4 in reduced form. But I tell you that on Friday you will have this, so I go to this unit circle, and on this particular unit circle, the tangent's not there, but it would be here, and I see 3 pi over 4, and I see 135. Okay?